Mine is numbered. Weird, I forgot. Oh, all of that is. I don't know what happens in the table. Oh, that's 4. Oh, because it's out of order, that's why. Okay. Any others?
2B.
Oh, did you say one? Huh? Did you say one of them? No. Okay, we'll start with 2B and then we'll do 3. For part B, to plot another point, this just means that has whole number coordinates or order pairs that lies on a line that's parallel to line N and goes through this point. I'm sorry, this line L, and then goes through this point. So I need to find the slope of just this line first. And this is counting weird. So I can either do this algebraically or count the slope, but the graph is counting by 2s, so you would have to keep that in mind. I'm just going to find the slope algebraically. Which would simplify to -2/5. So how this is like in the middle, that's because this is really a odd number. So I know that's my slope. So my parallel line would have the same slope. And if it goes through this point M, which is this, I can use either my slope-intercept form or my point slope to find that. Which would be rather, slope-intercept or point slope? Okay. So that would be -3 equals our slope -2/5 times our x value -4 plus b. And I would use that and solve this. I don't need the equation. I just realized I might be doing too much. So I went to this line. Oh. Yeah, I don't need this part. So once I have that slope, I just need to plot another point that would be parallel to it. So if I went up a half would be like up 1. So up 1, 2 to the left 5 would be up over 1 to the middle, 2, 3, 4, 5. So that would be like -9, -1. Now you could have kept going, you could have plotted a point over here or a point down here. There were multiple answers for that one. Erica?
My line is like parallel to the line above it.
Yes.
But I didn't get the -9. I plotted it by doing -2/5.
Yes, but because this is going, these are counting by 2s, I can't just say, okay, because right now it's in the half, I can't say this is 1 and this is 2, and then over 1, 2, 3, 4, 5, because that would be a different point, but it wouldn't be the exact slope. Because that would be me going up 4 and over 10. Because the scale is weird. Okay. So that is one of the points you could use. The one I just had was, if you have another point, I can tell you whether that's right or not. What point did you have, Erica?
I was like right by -10. So I was like on the -10.
Yeah, I don't think that would have been one of
got it looks like it's somewhere around maybe somewhere around -6. Like y -6.
The y is -6.
Yeah, and x looks like it could be. I think it's like yeah, no, the x is -6.
Okay.
Yeah, it's just like -6.
I'm just gonna plot all the points and you can list them all, and then you can see if those work.
Yeah, that's what mine is.
Okay, that one. So it would be a +6, but then -7.
Okay.
And then 1, 2, 3, 4, 5. Would be 9. That was not in the middle. It was supposed to be. 1, 2, 1, 2, 3, 4, 1. And then there wouldn't be enough to do another one. That's which is 11. Okay, so one of these 5 points would have been your answers. 6, okay. Other questions on that one before we do 3? That one was difficult because of the scale. If it had been like 1 and 1, that would have been a little easier. Right, for number 3, my number 4, your number 3. I'm going to start with this one because it's already in slope-intercept form, so I don't have to solve anything. These are not the same, so they're not parallel. They are reciprocals, but one isn't negative, so those are going to be neither. And then for the first equation in part A, I would have to solve this, get rid of 2x by subtracting. And then if we're looking at those two slopes, we have 1/2, we have -2. Those are reciprocals and negative reciprocals, so those are perpendicular, which then by default C would be parallel, but we'll still solve those. So we would have to subtract 3x to the first one and get rid of 12x to the second. And then divide by 5 and divide by 20. So that we have y equals -3/5 x plus 9/5. And we have to simplify these. These can both be divided by 4. So -3/5 x. Oh, trying to see what that number was. 18. We can divide those both by 2. So these end up with the same slopes, so those were parallel. If you were doing this in Desmos, you also could have put these in, and they would have crossed and made that T, and these would have not crossed at all. So you could have also seen really those are parallel lines. Okay. Questions on that or any others? Okay. So today we're going to start word problems, which I know we love. But in order to be successful with our word problems, we're going to highlight or circle or underline things. So if you want highlighters, there are some back in the white container. Or if you have your own, I would get that out. the goal today is to get through, there are 4 different types of word problems we're going to talk about in general. We're not going to do all 4 types today, but we're going to go through at least 2 of them. So let's start with number 1. So in general, right now, all of the types we're about to go through are going to be, you're going to be given some M, given some B, and we're going to put it in our white quiz on x+b so we can solve for it. Now, on the quiz, on the test, that part, you won't see that, but you'll have to recognize, okay, I'm given this, so this is the type of equation we're going to use. So let's read through this first. For the county fair, you and your friends plan to attend the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If your parents give you $20, write and solve a linear equation to find how many rides you can go on. So we're going to find anything that stands out or anything you find important. Numbers are always important, so what numbers do we see? 5, 50, the 20. And then the question is always important. What are we looking for? What is that asking us? Okay, we do have to find the equation to do what? How many rides we can go on. So that part's really important because that's going to be what we end up solving for. So then, in this, then we can start to label, okay, what is what? If you see the word per, P-E-R, or for each, that's usually going to tell you that's your slope. So this per ride tells us this number is our M. If you have like a one-time thing, you only pay this once, you only do this once, that would be your y-intercept, your B. So in this case, that would be your 5. Because you only do that once, you only pay the $5 once to get in, and then you're in, and then you pay for rides and things like that. Your y value is usually a total. Do we have that? The 20. So that's the total amount you have. You can't go over that because then you don't have money. So that would be your y value, which means the number of rides we can go on would be our missing variable, our x. That's what we're going to be solving for. So once we know all of those pieces, then we can put all of those numbers into our equation and set that up. So y I know is 20. M I know is 0.5 or 0.5. X I don't know, so that's going to stay my variable. And B I know is 5. So once you get your equation, then we can solve this by doing what? How could we get x by itself? Not minus 0.5 because that's attached to the x, so we can't do anything with that yet, but we can subtract 5. And then to get rid of the 0.5, not multiply, divide. Both sides by 0.5. So in your calculator, go ahead and do that. 15 divided by 0.5. 30. And because these are word problems, we need to put labels or units or whatever. 30 what? What are we looking for? Rides. 30 rides. And then I I should be able to put this back in for x, and this should work. So if I did 30 times 0.5, or 30 divided by 2 would give me 15. 15 plus 5 is 20, so I know that works. Bless you. Do you have any questions on that one? So point, I didn't put the 0, but if you want to put the 0, I would just say put it as 0 point whatever, that way you don't mistake it as just 50 instead of 0.5. Okay. We're going to read through the next one and see if we can label anything before lunch, and then we'll sign. Okay, so in number 2, the Deep Creek Lake. While your family is visiting Deep Creek Lake, you and your mother decide to go boating. The rangers charge $6.50 per hour, in addition to a $25 deposit to rent a canoe. If you wish to rent the canoe from 12:30 to 3:30 p.m., write and solve a linear equation to find the total cost to rent the canoe. What stands out? 650, 25, 12:30 to 3:30, and what are we looking for? The total cost. Okay, so let's see if we can label a couple things. Of these 3 numbers, could we label any of those as y, m, x, or b? Which one is m? 650. Because of that per hour.
25 is the y.
Is that our total? Because here, we're looking for that total. Okay? So what we're looking for is y. We'll finish that when we come back. So because in this one, y is always your total, or in these problems, since we're looking for the total, that would be our y. That's what we don't know. So then what would the other 2 numbers represent?
25 is x.
So normally we can determine if something is our x or not by looking at this. Whatever is next to this, so like in this one, per ride, the number of rides was x. So that means the number of hours is going to be x. Which means this would be, because you're only doing this once. You're only paying $25 once to get this, and then you have it for as long as you have it.
I can't see.
You can't see. I guess everyone can so sit right here for right now, and then I'll adjust that. Okay. Before we start to put all the numbers in, we have to figure out how many hours this would be. Yes. So now that we have numbers for m, for b, for x, then we can start to put that in. So we don't know y, so that's going to say just y equals. Our m is at 650. Our x is 3, so we're multiplying that, and then we're adding 25. Now this one, unlike the first one, yes, we're still solving for y, but because everything is on the same side, we're really just multiplying and adding, getting whatever that total is. So you can do that all at once, or you can do that separately in your calculator. Yes.
For 650, that would be 650 prime or 650x.
When you multiply it, or
No, I'm saying like the question just says 650. Not x at the end, right?
so if we didn't know the number of hours, we would put x, yes. But because we know the number of hours, we're going to put in 3 instead. Why is this so small? both pieces. This will be 19.5 plus 0.5, so that y equals 44.5. Because this is a total, what would our units or label be? Dollars. Any questions on that? Go ahead, Erica.
So when we found our x, we just found it by figuring out how many hours it is, and then if that wasn't the case and they didn't give us hours, it would just be x.
Yes, but if they didn't give us hours, then they would have gave us the total cost.
So for number one, you wanted them to indicate that it was 30 for the rides. Would you not want them to indicate 44.50 for the commute drinking? Or is it okay just to say $44.50?
$44.50, because the dollars would be their
Indication that they understand for the rental.
yes.
Are we gonna take points away? We don't indicate like the rides.
The rides of the dollars, yes. Because you need to know what are you solving for, and these are real world problems, so we wouldn't just say. Typically in conversations, yes, we would, but in this, we want to be specific. Okay. For the next one, we're going to try one more together, then I'm going to let you try number 4, and then we're going to move on to the second one. Alright, so for the Toyota 4Runner, your parents have decided to buy a new Toyota 4Runner for $25,635. According to the dealer, the car will depreciate in value approximately $3,000 per year, which means it loses its value over time. Write and solve a linear equation to find how many years until the car is worth $3,135. So what is important there? Mm-hmm. Yes. How many years? Correct. Okay. So same as before, we gotta find what is y, x, m, and b.
I think it's 3,135
Is the y, because that's gonna be your total at the end. Sorry. I'm trying to make sure that I said that right. That's not, I'm confusing myself. Yeah, because I think that would be the total at the end, but then I'm thinking how it would be. Oh, yeah, okay. Because this one's not adding, that's why. Okay, what else?
Is there an m and 3,000?
Mm-hmm. Because of that curve.
and the B is 25.
Which means the number of years would be our x. Now, in this one, because it's depreciating, it's losing value. Instead of adding b, we're going to subtract b. So when we set that up, we have 3,135 equals our 3,000 times x, we don't know what that is, minus our 25,635. So as we start to solve this, what would be our first step?
Adding the 2,
What would that be?
I got 2,876.
and then divide both sides by 3,000.
Like
9.59. Is that the rest of it, or are there more?
No, that's it.
Okay. So when you get decimals, you have to think: could years be decimals? Could I have 9.59 of a year? Yes. So I could leave it like that. You could leave it. What I was going to say was, if there were more, you could round to the nearest decimal, or you can leave it exact. So 9.6 would actually probably be too much. So I'll just leave it as this, but it is years, yes.
How would 59 be in years? Is that days?
That would be, days and months. A certain amount of days and months. Do you have any other questions on that one before you try number 4? Do you have any questions?
So it's like we're using decimals and stuff now. Like it's okay to get a decimal.
Yes, if it makes sense. So, like, if we were looking for number of rides, could I have 0.59 of a ride?
No.
No, that wouldn't make sense. So just think about, would it make sense to have a decimal or not? If it doesn't make sense, then round. But if it does make sense, then keep it. Okay, try number 4, and then we'll come back. Okay, so in this case, this is kind of what I was talking about for the last column. In this one, if I rounded this, that would be a little too much because I don't have 40.03. I have only $40. So I would need to leave that at the 0.29. So like if I did that again, and we'll get just 0.29. Then I have a cent to spare, but I'm not going over the amount I have. And gallons could be something you have a decimal of, so that is fine. Okay. Any questions on that before we go on to the next section?
What we divided and calculated, I kept getting different decimals.
Okay, so it should be the 35 first. Because you're doing 35 divided by 310, not this one. So it's this one. The top. Can you go? You're after going. Okay, this next part, and we're going to be using this a lot for the next unit also, is if we're comparing two different things. Then we're going to be using our standard form, so we've used that a few times, we've seen it often. And our labeling is a little different in this one. So let's read through first. Excuse me. Okay, so 4 enchiladas. Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill came to $7.80. If the enchiladas were $2 each, write and solve the linear equation to find the cost of each taco. So what's important with that one?
How many tacos?
Yes.
780.
The number of tacos, the 780. That is also important. We have to follow that differently.
And then $2 each. And then find the cost of each taco.
Yes. So in this one, unlike what we were just doing, these are going to have more variables. The A and the B don't really matter. It doesn't matter which one you call A, which one you call B. The X and Y kind of same thing, except whatever A is related to X, those have to go together. So like enchiladas and the cost of enchiladas have to go together. I can't put this with tacos because that wouldn't make sense. So we can call, let's say, the number of tacos A. And if I'm looking at number of tacos to be A, then the number of enchiladas would then be B. And then since I have a cost for the enchiladas, that would go with B, so that would be Y. In this case, your total is C. So C is now your total, which means the variable we're missing is X. which makes sense because this is the cost of the tacos, and that's what we don't have. So once you have each of those pieces, just like before, put those numbers into this format, the ax plus by equals c. So 2 times x plus 3, we know y is 2, equals 780. Yes. Yes. Okay, so we can multiply the 3 and the 2. And then get rid of 6 first by subtracting. What would that be when we subtract? 1.8 or 1.80, either or. And then divide both sides by 2. What is x? Exactly. So 0.9, we could put dollars or cents, but not both. So you could say 0.9 in dollars, or you can say 90 cents, either or, but not like 0.9 cents, because that wouldn't make sense. Yes.
Is that the only way for how to solve it?
As opposed to, what other way did you have in mind?
I mean, I take 7.8, 780 minus 6 for the taco prices, or the tomato prices. And then it got me 1.8. And I did 1.8 divided by 2 for the taco.
So you didn't set up an equation, you just did that math?
Okay.
But this is setting up, the whole point of this is, can you set up equations and solve them? So you would not get full credit for that. No. Okay. Other questions on this before we move on? Okay. Number 6. For the school play, tickets at a school play cost $4 in advance or $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. What's important here?
The $4,
Mm-hmm.
the 440, and how many were sold at the door?
Now there's something else important. It's not in numbers, but it's in words. No tickets were sold in advance. That part, if I could speak, is important. So then, starting with these first two, I'll rewrite our equation up here. Ax plus by equals c. And then, after that. Which one do we want to say A is A, or which one do we want to say is B? Doesn't matter. Okay. Yes.
And then, is there a C? It's the total.
Yes. So this is C. So then we need X and Y. Which would that be? Because the B and the Y go together. So at the door, I'm looking for those two same words. So that's Y, which means this part would be our X, that in advance. So when we start to set this up, I have A, which is 4. If no tickets were sold in advance, what number would that be? 0. Plus 5, I don't know what Y is, equals my total 440. because we put in that 0, that part is just going to be 0, and we can divide both sides by 5. What is y? 88 what? Tickets would be fine. If you want to be more specific, sold at the door. Either of those is fine. Questions on that?
Why did you underline the two words? Is it B and Y? Oh, because of the
Yes, because B and Y go together. Okay, now this next one, there's some information they don't give you because it's expected you know some of this information. So let's read through it first. So for the piggy bank, Jessie's piggy bank has all dimes and quarters. The total value of the money in her piggy bank is $11.40. If Jessie has 36 quarters, write and solve a linear equation to find the number of dimes she has. What's important there?
is the old one.
Okay, that is important because we know what we're dealing with.
36 quarters and the number of dimes.
Now, unlike the other ones, we're missing numbers. So let's look at what we have first. We have a number of quarters. We don't have a number of dimes. So let's say we call that A and B or X and Y. It does not matter. Let's actually call that X and Y, just for purposes. The 1140 would be which variable? C, because that's our total. So we don't have A and B. If I were to set this up, and I'm trying to add up the total value, what do we think we need here? Division of what?
Well, we gotta figure out.
Because I couldn't just say 36 plus y equals this, because I'm missing some information. But if I'm looking for the total value, how could I add up value with dimes and quarters? How would I get to 1140? The amount. The value of the dimes, the value of the quarters. So that's the part they're expecting you to know.
So that would be your A.
So that would be your A, yeah. That would be your A and B. So then, because I labeled this X and Y quarters, this would be B. And then, I'm sorry, that was backwards. This would be A. And this would be his number of dimes. Okay. I had to make sure they went together. So then when I have my A and B, then I can put all that together. 0.10 in dimes. I don't know the number of dimes. Oh, I did that. I started with the wrong one, sorry. And then 0.25. And I know the number of quarters. I just switched those. Equals that total. So then we could multiply 0.25 and 36. Figure out what that is. I don't know what y is yet, but I'm going to solve for it. Subtract your 9 on both sides. And divide both sides by 0.10. What is y? 24 what?
Or times.
Dimes. If I got a decimal here, could that work? No, I can't have a decimal number of dimes. That wouldn't make sense. Okay, so also, if you get a problem like this and you get a decimal, you should know something went wrong because I shouldn't have a number of decimal of dimes or quarters. Okay, I want you to try number 8.
After being with my 8.
Who else got 75 rolls?
But the rest is
Good. We didn't. It's okay. We will practice. Did we have any questions about that one? I did want to mention one thing. If your final answer is a negative number in any of these problems, that should tell you something is off. Because we can't have negative rolls or negative dimes or negative whatever. Okay? So be mindful of that. Alright. For the remaining time, you do have a Delta Math on this, but it's due next week. This is in the Delta Math link. And that Delta Math will be mostly the first type that we did, not these, because it's a different type. So you could be working on that, or the parallel and perpendicular line that is due tomorrow if you have not finished that. So be working on one of those things.